Welcome to the course on machine learning and application. In this video, we will learn about mining association rules. The presentation is organized as follows. So we will learn about basic concepts, a priori algorithm, then the different data formats for mining, mining with multiple minimum supports, and mining class association rules. And at the end of the presentation, we will see the summary of this. Association rule mining was proposed by Agarwal and his team in 1993. It is an important data mining model studied extensively by the database and data mining community. It assumes that all data are of categorical data type and there is no good algorithm available for the numeric data type. Initially, it is used for market basket analysis to find how items purchased by customers are related. For example, if a customer buys a bread and then she buys milk and then the support is 5% and confidence is 100%. So we'll see what is support and confidence in the next slides. Now let us discuss about the model of that particular association rule mining. The data is set of items, so I is set of items I1, I2 and IM, and transaction T is set of items, that is T is subset of I, and the transaction database capital T is a set of transactions T1, T2 up to Tn. Transaction data, or we can call it a supermarket data, is a set of transactions of all the items. So let's say T1 is having bread, cheese, milk, T2 is having apple, eggs, salt, yogurt, and like that Tn is having biscuits, eggs, milk. So the concept is that an item is nothing but an item or article in the basket. The I is nothing but set of all items that is possibly sold in the store. And a transaction is the item purchased in a basket. It may have a transaction ID or it may not have. And a transactional data set is set of transactions. So we can think about a particular set of documents. So if we want to classify documents, then let's say a text document data set is considered, and each document is treated as a bag of keywords. So for example, document 1 has the keywords as student, teach, school. Document 2 has keywords as student, school, and like that document 3, 4, 5, 6, 7 has different bag of words. Then depending on those bag of words, we can classify whether this particular document is related to, say, probably a school, or maybe it is related to a sport. So a transaction T contains X, a set of items, obviously in the item set, in I, if X is subset of T. An association rule is an implication of this particular form, X tends to Y or X followed by Y, where X and Y are belonging to the particular set of item set, and X intersection Y is not equal to 5, means X and Y are different, is equal to 5, sorry, X and Y are different. An item set is a set of items, that is, for example, let's say consider X is equal to milk, bread, cereal is an item set, and a K item set is an item set with K items. So a 3 item set will obviously include only 3 items, so milk, bread and cereal. The rule strength measures. So what are the different measures which will find out the strength of the rule? So support is one of that. So a support is nothing but the rule holds with the support in, say, sup in T if sup percent of transaction contains X union Y. So the probability of X union Y is nothing but the support. So if we have, say, 10 transactions, then how many transactions are supported with that X and Y? So that will be the support. And confidence is the value of the particular rule T which holds that particular confidence value. So is nothing but the probability of Y given X, means how many transactions having X has Y. So that is what is the confidence of that particular confidence value of that particular rule. An association rule is a pattern that states when X occurs, Y occurs with certain probability. So the mathematical model of the support and confidence is given as, The support count of an item set X denoted by X dot count in a data set T is the number of transactions in T that contain X. Assume that the T has n transactions, then the support is given as X union Y dot count, that is the number of transactions having X and Y divided by the total number of transactions n, and the confidence can be given as X union Y dot count, the number of transactions having X and Y both, divided by the count of X. So how many transactions are having X and Y out of the total number of transactions having only X, having X. The goal of this particular rule is to find all rules that satisfy the user specified minimum support and minimum confidence. And the features are that completeness, that we have to find all such rules and no target items on the right hand side. So we are finding out the rules irrespective of the particular target set, target item, and mining with the data on hard disk, not on the memory. So let us consider this particular example. So T1, T2, T3, T4, T5, T6, T7, we have 7 transactions having some items like beef, chicken milk, beef cheese, cheese boots, and like that. So assume that the minimum support value is 30% and minimum confidence is 80%. So if we consider chicken cloth milk, so the support is 3 by 7, because you can see that the total number of transactions are 7 and there are total 3 transactions having chicken cloths and milk. So this is 1, this is 1, 2, and this is 3. So 3 transactions are having, so the support is 3 by 7, and the rule is from the item set is like clothes given milk and chicken. So the support is 3 by 7 as what we have seen, and the confidence is 3 by 3 because the transactions having clothes milk chicken is 3 divided by milk and chicken. So you can see milk and chicken had occurred in 3 transactions, and like that clothes chicken milk, so the support is 3 by 7 and confidence is also 3 by 3. So transaction data representation. So we can have a simplistic view of shopping basket and some information which is important that is not considered, that is the quality of each item purchased and the price paid. So this is not included in the transaction data. And there are many mining algorithms available for this. There are a large number of them. So they use different strategies and data structure, and their resulting set of rules are all the same. Given a transaction data set T and a minimum support and a minimum confidence, the set of association rule existing in T is uniquely determined. Any algorithm should find the same set of rules, although their computational efficiency and memory requirement may be different. Now we will study only the a priori algorithm. In the a priori algorithm, it is probably the best known algorithm for association rule mining. There are 2 steps. The first step, we find all the item sets that have minimum support, the frequent item sets, or also called as large item set, and we use the frequent item set to generate the rules. For example, a frequent item set may be chicken, cloth, milk, which is having support 3,7, and one rule from the frequent item set is clothes given milk and chicken. In the step 1, we mine all frequent item set. A frequent item set is an item set whose support is greater than or equal to minimum support. And the idea behind this is that the a priori property, download closure property, any subset of a frequent item set are also frequent item set. So as we can see that A, B, C, D are the 4 items, and out of that only A, B, D are frequent item set. So any subset of that particular frequent item set is also frequent item set. So AB, AD and BD are the frequent item set. And in the iterative step, also called the levelized search, we find all 1 item frequent item set, then 2 item frequent item set, 3, 4, and we'll go up to k. In each iteration k, only consider item set that contain some k minus 1 frequent item set. So the steps are like find frequent item set of size 1, that is f1, and from k is equal to 2, that is find ck, candidate of size k, those item set of size k that could be frequent, given having f of k minus 1, and fk is those item set that are actually frequent, and fk is subset of ck, and need to scan the database once again. So let us have this particular example. So here we are having only 4 transactions, and in the first transaction we are having item 134. In the second we are having 235. In the third we are having 1235, and in the fourth we are having 25. So in the first step, as we can see, we will scan through the transaction database, and we can see that one is having 2 occurrences, 2 is having 3 occurrences, 3 is having 3 occurrences, 4 is having 4 occurrences, and 5 is having 3 occurrences. So the frequency of occurrences are for 1 is 2, 2 for 3, 3 for 3, 4 for 1, and 5 is 3. And then our minimum support is 0.5, that it should have at least supported by 2 transactions. So we'll have 1, 2, 3, we will just discard 4. So we'll have item 1, item 2, item 3, and item 5. In the second phase, we will take the we'll combine all those keys. So 1 2 1 3 1 5 2 3 2 5 and 3 5, and then we'll again scan through the database and find out their frequency of occurrences. So as you can see, 1 3 is having 2, 2 3 is 2, 2 5 3, and 3 5 3, 3 5 2. The rest of the things are eliminated because they are less than the minimum support. And then in the third phase, we will combine all those. So we'll combine 2, 3, and 5, and we will scan for 2 3 5, and the keys are 2 3 5, and then you can have the rule of 2 3 5. Thank you for watching this video. If you like this video, please press the like button.